David Smith here with another flipped classroom math video. A few tips before we get started. Remember, you can always pause the video if you need to catch up with your notes. You can also speed up or slow down the playback if that helps. Finally, you can turn on the captions so you can see my words going by at the bottom of your screen. Today's topic covers horizontal and vertical shifts of sine and cosine. So what we have here are two kind of general equations with our various letters for our variables for our transformations. So we have y equals a sine of b times x minus c, no longer just bx, but x minus c plus d. And the same thing for cosine, same letters over there. Okay, let's quickly review the two parameters that we played with in our last lesson, namely a. The absolute value of a is the amplitude, okay? So if a is negative, then the graph is flipped over the x-axis. It's just a mirror reflection over x. So that's the amplitude. B relates to period, and the period is either 2 pi over b or 360 over b. And we manipulated these two in the last lesson. So here's the two new ones. C shifts the graph horizontally. So this C in here that you're subtracting from theta is going to shift the graph back and forth horizontally, and then this D out at the end is going to shift the graph vertically. So let's take a look. All right, let's work an example. And I'm going to do this in two stages. I'm going to make two graphs along the way to getting the complete graph, because there's a lot of stuff going on with this one example. So let's take a look at the equation. 2 is my A, that's my amplitude, wrote that there. My period is going to relate to the 3 that's outside of this part. So my period is going to be 2 pi over 3. Remember, it's 2 pi over b. I'm using pi's because I'm seeing pi here and I'm seeing pi here on my range. My shift, x plus pi, means I'm going to shift to the left. Remember, whenever you have these things inside parentheses, you just got to remember to change the sign. So I'm going to shift this to negative pi to the left. That's the one we're going to handle with a second graph. And then finally, my vertical translation is going to be down -1. My d is -1. Okay, so let's start by sketching in our axes. Notice how my amplitude's 2, but I'm starting 1 down. So my max is going to be +1, and my minimum is going to be -3. So I'm going to go ahead and do this like so. Here's my 1, my 0, my -1, -2, and -3. Now, a pro tip for making your sine function are draw in your parameters first, then sketch your graph. So I'm going to go ahead and put in my principal axis. This is y equals -1. That's the axis about which the function is symmetrical. And then if you like, you can actually dash in your max and your min lines. And that helps sketch your function. You don't have to, but it helps. And then I'm going to make my sine graph go up to the max, down to the min, and back up. Okay, so there's my sine graph. It's a little bit wobbly, but it's good enough. Now, this point, this is a full period. My period is 2 pi over 3. I can say 2 pi over 3 right there. Now this point, that's the halfway point. So what is that going to be? 1 pi over 3. So this is pi over 3. Now this point is half of that one, so that's pi over 6. Now one of the ways I like to count through my radians is in pi over 6s. So this is 1 pi over 6. That's 2 pi over 6, which reduces down to pi over 3. This would be 3 pi over 6, which is pi over 2. So that's this one for the minimum. So this is pi over 2, 1/2 pi. And then again, here we are at 2/3 pi for 1 period of our function. So that gets us the graph of just 1 period. Notice how we haven't gone all the way to 2 pi yet, but we got the idea of the vertical shift and the period in our function. Okay, now we're ready to create the full graph. Now what I did is I put our work from the last board right over here, And I've done the same thing. I just made it nice and tiny so we have it for a reference. And I extended my graph one more pi over 6 radians so I can get to pi. Now think for a minute, why did I need to get to pi and see what my curve is doing? Okay, if you realized that what we need to do is we need to shift the whole graph pi radians to the left, you're right. So instead of starting here in the curve, we're going to start here because we're starting at pi radians inside our function. It's still going to be 0 radians on the graph, but it's when we have pi for x that we're going to subtract, and we're going to end up with pi radians starting right there. All right, let's figure out some points. Now this first step is going to be tricky, okay? So what I did here is we're going to start right here at the principal axis, and then check it out. We noticed that from this graph, we're starting at pi. So at pi, we're at the peak. So that means we're going to go down from here first because we're at pi. So now we're going to go down to the minimum, which is at 3. And remember, we go by pi over 6s, pi over 6 to the max, another pi over 6 to the axis, another pi over 6 to the minimum. So my next point is going to be pi over 6 minus 3, and then pi over 3, we're back at minus 1, and then at pi over 2, we get up to positive 1, and then at pi over 3, we are back at our principal axis. So here's our graph. Come down, up, back down, okay? Kind of interesting, right? We did the reverse because we're starting at pi. Not because we have a negative amplitude, just because that's where we're starting our function. Okay, now let's get some more points. All right, let's finish up this graph. Shouldn't be too hard from now. I can march along my axis in increments of pi over 6. Remember, you need to be adept at reducing or expanding up these fractions because that's really helpful. So I've done my 1 period. Now I'm going to go down to my minimum at 5 pi over 6. One more pi over 6 gets me to pi. And then another pi over 6 is at 7 pi over 6. And then twice my period is right there. And that makes sense. My period is 2 pi over 3. So twice that is 4 pi over 3. So now I can get my second period of my graph. Remember, I have to put all the cycles of the graph that fit in 0 to 2 pi. And we have this multiplier here. So that means we're going to fit more than 1 period in this range. Okay, I've got, looks like 1 more period. I'm going to come down to 3 pi over 2. And then I'm going to come back up to the principal axis at 5 pi over 3. I'm going to get a max again at 11 pi over 6 and come back down to my principal axis at 2 pi. Funny how that works out. I go down and up and down. Okay? So I got 3 full periods in my range. I shifted down 1 because I had a vertical translation of minus 1, and then I had a horizontal translation of negative pi. Now, this is just a tricky thing. When you see a plus there, you just gotta remember that it's subtraction. This is just like with a quadratic equation in vertex form. You'll remember that its vertex form looks like y equals ax minus h squared plus k. The minus is part of the formula, so if you see a plus there, it means you're going left. Okay, so hopefully this gets you going. I know that was a pretty complicated example, but I handled everything that you could do with a trig function. Thanks for watching. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.